Hi ladies and gentlemen, this is Mr. Green again, and this is another in my series of Algebra 2 lessons. We're continuing on through our trip through imagination in Chapter 7. We are going to be looking at more dealings with complex numbers, but this time we're going to be multiplying and dividing complex numbers, and we're going to show you how to do that. And then we're also going to talk about something called a conjugate of a complex number, and we're going to multiply a complex number by its conjugate and see what we wind up with. Okay? So, the joke for today, the number you have dialed is imaginary. Please rotate your phone by 90 degrees and try again. Something right out of the Matrix or something like that. Ooh, doesn't really fit. Okay, here we go. So, if we're multiplying things, what we're going to do is what we're going to do is we're going to take this and use the distributive property. And we're just going to multiply it times both of these two numbers. It really is just the distributive property. When I multiply 7i times 3, I get 21i. So I just turned a real part into an imaginary part. I'm going to multiply the 7 times the 2, and I'm going to get 14. 14i squared. Well, what's I squared? That's going to be a negative 1. So this is going to be a negative 14. 21i minus 21i minus 14. You know what? That should be written as negative 14 plus 21i. That's the correct order to write them. And that would be my answer that I would have for this one. For this one over here, I'm going to follow the same rules that I followed for multiplying things with a variable in them. Basically, FOIL. That's right. I'm going to multiply the 8 times the 4. 8 times 4 is 32. I'm going to multiply the 8 times the 7i. And what am I going to get? I'm going to get a 56i. I'm going to multiply the negative 3i times the 4. And that's going to give me a negative 12i. And I'm going to multiply the negative 3i times the 7i. And that's going to give me a negative 21i squared. Okay? So you can see we've got squared terms and constant terms. I squared, that's negative 1. So negative 21 turns into a positive 21. I can combine the 12 and the 56, giving me 68i. And I've got out front 32. So when I add these 32 and 21 together, I get 53 plus 68i. That would be my answer for this one by multiplying these two together. Okay? Let's go forward here. What happens when we multiply by its conjugate? Well, first of all, I have to define what a conjugate is. If I've got something that is a plus bi, a conjugate is simply taking that plus sign and turning it into a negative sign. And so I would have a minus bi. What that actually is if you look at what we were doing last time with the modulus, both of these two numbers will have the same modulus. They'll be the same distance from the origin. Why? Well, a squared plus b squared, or a squared plus negative b squared. Well, negative b squared is going to be b squared. So what am I winding up with? Something that that is, both of these will be the same distance from the modulus. So if you added these two together, what would you get? The imaginary parts would cancel out, and you would wind up with 2a. You multiply them together, and what do you get? You get a squared plus b squared I squared. Well, that I squared goes away, and you're left with a squared plus b squared. That's the, guess what? That is the Pythagorean theorem, c squared. Okay? So that's what we're talking about here. Conjugate pair. And that's how you find it. So if I were looking at 6 plus 2i, 6 minus 2i, 36 plus 4i squared. Well, I squared is negative 1, so this becomes 36 minus 4, or 32. Do you see how that was done very simply? Okay? Let's write another one. The quotient in standard form. If I see something like this, the reason I had to have the conjugate was to rationalize this like we did the uh, square root functions, and to rationalize this like we did the imaginary numbers, we need to multiply this by its conjugate, 2 minus 3i, divided by 2 minus 3i. When I do that, the bottom down here becomes a rational number, a positive rational number. 2 times 2 is 4. Let's see here. 4 plus 9, which is equal to 13. That will be my denominator. On the numerator, I need to use the FOIL method. 1 times 2 is 2. 1 times negative 3i is minus 3i. I times 2 is going to be a 2i. And then I times a minus 3i is going to be a minus 3i squared. Well, that's going to make that into a minus 3. Okay, plus 3. 3 plus 2 is 5. So what am I going to wind up with? I'm going to wind up with 5 minus I over 13. That would be what that is. So that is my answer. Okay? So let's look at what happens. What are we going to do here? Well, if you read this whole thing, they're going to have you go through some examples of what happens to the modulus of each product. If we multiply times 1, we get minus 1, or 1 and then a negative 2. We're talking about right there. And if I find the modulus of that product, of doing that, I get 1 minus 2i. That's my value that I get when I multiply that out. And if I look at the modulus of that number, I'm going to have 1 squared minus 2i squared, which is actually 2. So I'm going to get 3. And my modulus is 3. That is the distance, right? 1 plus is 2. Yep, that's what it is. Okay? That's my distance. So let's move forward here. What happens to this one? When I multiply this out, I get 2i minus 4i squared. Well, that becomes the plus, and that becomes a 4 plus 2i. I could graph that. There's 2, there's 4, there's 2. It's right there. My modulus is going to be that distance there, right? So I take the modulus of that number, and I get 16 plus 4i squared. Well, that's negative 1. So 16 minus 4, that's 12. That's my modulus. Let's look at this one down here. When I multiply these out, 1 times 1 is 1. 1 times minus 2i is minus 2i. Okay, minus 2i times 1 is a minus 2i. And minus 2i times minus 2i is a positive 4i squared. Well, that becomes a negative 4. Negative 4 plus 1 gives you a negative 3 minus 4i. 2i plus 2i is negative 4i. So we're looking at negative 3, 1, 2, 3, negative 4, 1, 2, 3, 4, be right here. And what would my modulus be in this situation? Taking the modulus of this, I get 9 plus 16. Oops, 16i squared. I squared. Well, 16i squared is negative 16. That would be a negative 5. Was there 16, 7, 8? 7? Yeah, negative 7. If I'm taking the square root of negative 7, wait a second, Mr. Green, you said the modulus was always a positive number. It is. 9, 16, negative 1, so I'm taking 9 minus 17. 9 minus 16, I got a negative number. Have to check that one. But that would be my modulus on this one. Can you see the differences between these that I got? Let's see, did I multiply that right? Wait a second. Did I do that right? Minus 4, that'd be a minus 3. So, taking the modulus, minus 3 squared gives you a 9. Okay? And a minus 2, and a minus, let's see here, minus 2 and a minus 2. That's minus 4i. So I take the square root of that, I get 16i. Oh, it's a minus 16i squared, so that becomes a positive 16. So that becomes the square root of 25, which is equal to 5. I knew I made a mistake there somewhere. I knew it had to be a positive 5. So I got a positive 5 on that one. So look at these moduluses. Is there any way that you could justify that if 1 minus 2i has a modulus of 3, and I square that, multiply it times itself, I get 5? That doesn't make a whole lot of sense. You can't say that 3 times 3 is 5. This is the world of the complex numbers. Okay? This is the world you got to be careful with. And that's what they're trying to tell you right here. The effect of multiplication can be demonstrated by graphing the product and examining the distance from the origin. Okay? It's really kind of screwy how it works. Okay? Be very, very careful with it. So, having said that, if you have questions, and I'm sure you're going to, I would, please come by and ask your questions so that we can get them answered for you, because I want to make certain I'm getting your questions answered. So, I'll look forward to hearing from you next